Hi, I am Blaine Radler, and this is the first in a series of 10 short instructional videos covering the basics of digital design. Although this course stands alone, it also serves as an introduction for two of my books. One, Practical VHDL, and the other, Hands-on VHDL, which is actually just the cover, but by the time you see this, this will be available as well. Thanks. Hello, and welcome to U of Blaine. That's me. These are online mini-courses presented not as comprehensive substitutes for actual college courses, but perhaps introductions to them, or maybe reviews for those who've already taken them. These courses are broken up into digestible sessions, each one between 5 and 10 minutes long. So, let's get started with the most basic concept of digital design, binary numbers. We're all familiar with the differences between analog and digital things. Analog devices have a basic property whereby they operate in some way continuously. The hands of the analog clock sweep around unchecked. The needle of the record player glides along, swaying up and down along with the physical representation of the music. Digital devices, on the other hand, have an aspect of changing in discrete steps. The minutes of a digital clock click ahead once every 60 seconds. But what about a CD player? The disc is spinning continuously, just like a vinyl record. If we could see the signal created by the phonograph needle, like we could with an oscilloscope, it might look something like this. To create a digital version of this, we sample the amplitude of the signal at periodic intervals. And we're left with these discrete samples. They comprise the discrete digital steps. Just as the clock clicks ahead in increments of minutes, the digital form of the sound clicks ahead from one amplitude sample to the next. Except instead of minutes, the steps here are microseconds, millionths of a second. We can assign some amplitude values to the samples. The units here might be volts, or more likely millivolts, thousandths of a volt. If this sample is 10 units, this one might be 8 units, and this one 4 units. The question remains how these amplitude units are represented in a digital device. Obviously, there's no numeral 8 or 10 flying around the CD player's internal circuitry. We've all heard the standard bit of wisdom that digital devices run on a bunch of ones and zeros. Well, in fact, it's true. These are binary numbers, as you may have learned in math class, where each character location in our familiar decimal numbers represents a power of 10, so that the second position is times 10, the third times 100, etc. Because each position is times 10, the character can range from 0 up to 9. Binary numbers, on the other hand, are positioned by powers of 2. Since the first position, the least significant bit, is times 2 to the 0 power, it's just times 1. In the third position, in this case the most significant bit, is times 2 to the 2, or times 4. Adding them up, we get a decimal 7. We often add a letter D to indicate that it's a decimal number. Whereas decimal positions can go from 0 to 9 in binary, they are either 0 or 1. As we go up from the LSB, each position is 2 times the previous. So a binary number like this is 64 plus 16 plus 2, or decimal 82. Binary numbers can get pretty long, and so we often segment them into groups of 4. And in this case, the upper group would be a decimal 5, and the LS group a decimal 2. We call this grouping hexadecimal, or more commonly just hex. And we place the letter H ahead of the groupings to indicate a hex value. Instead of a D, you might see hex values that begin with a 0x, which is how they're often written in software code. But what happens when the group of 4 binary characters is greater than 9? After all, if you add up 8 plus 4 plus 2 plus 1, the maximum amount that they can be, it could be as high as 15. Do we write it as 10-2? Nope. Instead, we assign letters to the numbers 10 through 15. So in this case, where our MS hex group is decimal 10, we write it as A2. Here's the binary values with their hex representations. And here's an exercise for you. I'll show the answers at the beginning of the next session.